Welcome to Knowledge Speaks. Today we're diving into one of the most essential concepts in C programming, constants. What are they? Why are they important, and how are they used? Let's find out.
A constant is a value that doesn't change during the execution of a program. It stays fixed like a rule of the program universe.
Console are mainly divided into two types: numeric constants and non-numeric constants. Numeric are further divided into integer and real. Integer are divided into decimal, octadecimal, hexadecimal. Real are divided into fixed form and exponential form. Non-numeric are divided into character and string.
Numeric constants. A numeric constant is a numeric value It is any combination, digits from 0 to 9, and the only allowed special characters, namely plus, minus, and .ni. A sign may precede a numeric constant. It can be either a plus sign or a diver sign. If both signs do not appear, it is assumed to be positive. Commas and blank spaces are not allowed in a numeric constant. A numeric constant cannot exceed its limit. Examples of numeric constants: plus 89.56 minus 234.0, 999.0, valid. 78.90 to plus minus 234.80, 10,000.75, 40. 506.90. Sign must precede the number. Both signs cannot appear. Commas not allowed in a numeric constant. Blank spaces are not allowed in a numeric constant. These are invalid constants. Integer constants. An integer constant is a numerical value that does not have a fractional part. Rules for writing integers constants. 1. It is any combination of digits from 0 to 9, and the only allowed special characters, namely plus and minus. 2. A sign may precede an integer constant. It can be either a plus sign or minus sign. If both signs do not appear, it is assumed to be positive. 3. Commas and blank spaces are not allowed in an integer constant. 4. An integer constant cannot exceed the minimum of minus 32768 and a maximum of plus 32767. Examples of integers: plus 789 minus 5,634, 239. These are valid integers. 67.90 plus minus 789, 348 plus 9,999.7534567 cannot have a fractional part. Only one sign can appear. Sign must appear before the integer constant. Comma and decimal point not allowed in an integer constant. Exceeds the integer range. Invalid integer. Types of integers. There are 3 types of integers. They are number 1 decimal integers, number 2 octal integers, number 3 hexadecimal integers. Decimal integers. A decimal integer is made up of digits from 0 to 9, 10 symbols, and the only allowed special characters, namely plus and minus. Plus 789, minus 5,634, 239. These are valid integers. 67.90 plus minus 789, 348 plus 9,999.7534567 cannot have a fractional part. Only one sign can appear. Sign must appear before the integer constant. Comma and decimal point not allowed in an integer constant. Exceeds the integer range. Invalid integer. Octal integers. An octal integer is made up of digits from 0 to 7, 8 symbols. It should be preceded by a leading zeros. Then only it is recognised as an octal number. Example: 033 is an octal number. 33 is not an octal number. Decimal to octal conversion. Let's start with converting a decimal number to octal. Our example, the number 27 in decimal. Divide 27 by 8. The quotient is 3 and the remainder is 3. Now, write the remainders in reverse order and we get 33 and divived. So, 27 in decimal is 33 in octal.
Now let's reverse it. Convert 33/8 back to decimal. Multiply each digit by powers of 8. The first 3 is in the 8 superscript 1 place, and the second 3 is in the 8 0 place. Add them up. And you get 27 in decimal again.
Hexadecimal integers. A hexadecimal integer is made up of 0 to 9, A, B, C, D, E and F, 16 symbols. It must be preceded by OPX symbols written without any space between them. For example, OP1B is a hexadecimal integer. Decimal and hexadecimal conversion and vice versa. Let's start by converting 27 in decimal to hexadecimal. We divide 27 by 16. The quotient is 1 and the remainder is 11. Now remember, in hexadecimal, the number 11 is represented by the letter B. So 27 in decimal becomes 1B in hexadecimal. Let's convert 01B back to decimal. We multiply 1 by 16 raised to the power of 1 and 11 by 16 raised to the power of 0. That gives us 16 plus 11 equals 27. We've successfully converted hexadecimal 1b back to decimal 27.